When we look up at the night sky, we're not just staring into darkness. We're looking into deep time and across billions of light years of space. But where does it all end? Does the universe have an edge? And if it does, what lies beyond? These are some of the most profound questions in modern cosmology, and the answers are as fascinating as they are elusive. Let's begin by asking, what do we mean by edge? In everyday life, an edge implies a boundary, like the edge of a table or a cliff. But space doesn't behave like objects in our daily experience. Instead of being a finite structure floating in a larger emptiness, space-time itself is what expands. The universe isn't expanding into anything. Rather, it's stretching space itself in all directions. Currently, the observable universe, what we can detect using light and other signals, is about 93 billion light-years in diameter. This doesn't mean the universe itself is only that big. It's just the portion we can see, limited by the age of the universe and the speed of light. Since light has a finite speed, and the universe is about 13.8 billion years old, you'd expect we can only see about 13.8 billion light-years away. But because space has expanded during that time, objects we observe today were much closer when the light was emitted. Due to this expansion, the observable horizon is much larger. So does this mean there is an edge beyond this observable bubble? Not necessarily. Most models suggest the universe is either infinite or so large that it may as well be. In the case of a flat or open universe, space extends forever. Even in the case of a closed universe, like the surface of a sphere, the universe could be finite but unbounded, meaning you could travel forever without encountering a wall. Still, some physicists propose that the universe could be a higher dimensional shape, and what we perceive is just a slice or projection of this structure, similar to how a two-dimensional being would perceive the surface of a sphere without knowing the third dimension. This leads to the idea of a hypersphere or a multiverse, where our universe is one bubble among many. What about actually going to the edge? Here's where things get complicated. Even if the universe had a physical edge, we would never reach it, at least not with our current understanding of physics. The universe is expanding, not just space between galaxies, but space itself is growing faster and faster. This phenomenon is driven by dark energy, a mysterious force that makes up around 70% of the energy in the universe. Because of dark energy, distant galaxies are receding from us faster than the speed of light. Not violating Einstein's relativity, but rather because space itself is expanding. This means that there are regions of space we will never reach or even see. They are forever beyond our cosmic horizon. Even with the most advanced spacecraft imaginable, those places are inaccessible, not because of distance alone, but because they're moving away faster than light can bridge the gap. From a practical standpoint, how far we can go is not about how fast we can travel, but about the nature of the universe itself. Cosmological horizons set a fundamental limit. That said, within our local group of galaxies, our cosmic neighborhood, gravity holds things together more tightly than expansion can pull them apart. We will always be able to explore the Andromeda galaxy, for example, which is even moving toward us and expected to merge with the Milky Way in a few billion years. One final thought. Just because we can't reach the edge doesn't mean we can't understand it. Through the study of cosmic microwave background radiation, redshift surveys, and gravitational waves, we're piecing together the shape and fate of the universe bit by bit. New missions like the James Webb Space Telescope and upcoming Euclid mission aim to expand our understanding even further.